Welcome, everyone. Thank you for joining us today. Today, we have the pleasure of hearing from Chandra Pathivada. Chandra will be presenting on PostgreSQL for MSSQL Server DBAs.
Hello everyone, this is Chandra Pathivada from Amazon Web Services, and today's session is on Postgres for SQL Server DBAs. A quick introduction about myself before heading into the session. I'm a database specialist solution architect, primarily focusing on assisting customers migrating from commercial databases to open source engines such as PostgreSQL. I have over a decade of experience on both Microsoft SQL Server and Postgres. And here I put together all my learnings during my transformation to become a Postgres DBA with my background on SQL Server. I hope this session helps you to kickstart your learning, and at the same time, I also would like to learn from you. So please provide your feedback in the comment section during or after this presentation. And here I would like to share another workshop that we okay. So here we also want to share an update on free workshop that we offer to our customers from AWS. It's called Postgres for SQL Server DBAs. So this workshop has 22 modules, including modules on development, architecture, performance tuning, and how to make a precise GenAI prompts for code conversion, along with options to migrate and support programs from AWS to accelerate your migrations. So this is a 6 hours workshop that we offer free to our customers. But the session today covers the key topics in this workshop. But if you want to have a complete hands-on workshop for your team, you can reach out to us through clicking the link at the URL on the right side of the slide, so that we can schedule this for your organizations. Okay. So, all right. So before heading on to our actual 1 hour session, let me ask you a quick question. So since we have GenAI tools where most of the conversation can take care by GenAI tools itself, do we need to learn Postgres? So here my short answer is yes, because using GenAI, you can accelerate code conversion, but it's you as a DBA or a developer should make the ultimate decision before applying any changes to production. So in a short, you should know about your target database, in this case it's a Postgres, compared to your source, which is SQL Server, so that you can build right indexing strategies, understand the pros and cons of when applying any feature with any workarounds, when migrating these applications, and so on and so forth. Okay. And the second reason why you need to learn Postgres is for your career, to become a cross database specialist on cloud. So one of the best way to learn your target database engine is because there are so many learning techniques that are available, but the one such learning technique where I applied to learn Postgres using my knowledge on SQL Server is a quantitative analysis. This is one of the learning technique that you can use through compare and contrast everything between these two database engines to learn your target database. In this case, it's Postgres. And we are using the same format throughout the session, okay, to make it short and make it as a fast track mode to learn Postgres. Okay, so with that said, let's head on to the agenda. So here, the way how I structured this is, first we will start off with the development related differences, which is on the left hand side on this agenda, following with DBA related activities such as security backups, monitoring, on which are listed on the right hand side of the slide. Okay, so let's start with what is this Postgres, and why customers are migrating to Postgres. Okay, the top one reason is the licensing, move away from licensing costs. And that too, if you migrate to any open source database such as Postgres on cloud, then you can take advantage of cloud as well. And here, Postgres, if you compare Postgres with the SQL Server to start off with, Postgres is an ORDBMS. That means it's an object relational database management system, where SQL Server is a relational database management system. Okay, that means Postgres as an ORDBMS, along with its relational database feature, it also brings object-oriented characteristics such as supporting inheritance and polymorphism. Okay, so here in Postgres, you can achieve inheritance through creating a table type and inherit to n number of objects. Okay, this is let's say, for example, here I can show an example in the next slide. So here you can create a table type, and you can inherit this table to the other tables. Okay. Though this is not very common in most of the workload, but it's good to know about these differences, as you may need this for a specific workload that you may encounter in future. Okay. So here, this is an example where you can create a table, the table as in car, and you create another table called sedan, and you can inherit all the properties. That means all the columns from this table car into sedan. Okay, by using a command called inherits. Okay, when creating a table. So when you inherit the cars table into sedan, and when you run select star from cars, and when you run select star from the sedan, then along with the columns what this table sedan has, it also inherits all the columns from the table car. So this just is a high level example on how Postgres supports inheritance. Okay. And the next one is polymorphism. So here I just want to give a very high level example on how Postgres supports polymorphism. So in Postgres, you can create functions with the same name but with different parameters. Okay. But in Postgres, but in SQL Server, this is not allowed. You cannot create you cannot create two functions with the same name. But in Postgres, you can create multiple functions with the same name as long as the parameters are different from each other. Okay. So this, I just want to show this as an example on how it supports polymorphism, because polymorphism means when you change the parameters, it should behave differently, right? Yeah. Okay. And extensions. So here, the power of Postgres comes with extensions. Yeah. SQL Server also supports extensions, but these are the external extensions. But in Postgres, using these extensions actually can change the behavior of this execution, because it can intercept the query execution and optimizer. That's a major difference. And here I just highlighted some of the extensions where mostly I use. Okay, that includes pgportman. Pgportman is an extension that you can use for the table partitioning. And for pgcron, this is to scheduling jobs in Postgres, because in SQL Server you will be using SQL Server agent, but in Postgres there is no SQL Server agent. But instead that you can create an extension and use the pgcron to schedule your jobs. And for linked server, we have foreign data wrapper extension in Postgres. And if you're using AWS Aurora Postgres, then you can use an extension called AWS S3 Commons. So using this extension, you can directly export your data using an SQL statement to an S3 bucket. And the last one is Babelfish for Aurora Postgres. So Babelfish for Aurora Postgres is a product from AWS, okay, which is built on Postgres, and we made this using extensions. So here I just want to show you how Postgres is highly extensible, because all these extensions because these extensions are community driven, and that makes Postgres highly extensible. All right. Case sensitivity. So this is very important for the DBAs migrating their applications from SQL to Postgres. Why? Because SQL Server is you can make it as a case insensitive or sensitive at any level, at the instance level and the database table column. At various degrees, you can apply this case insensitivity or sensitivity with different correlation settings, right? But Postgres is purely case sensitive. And but there are some options available to make it as a case insensitive that I will cover it in the next slide. But remember that Postgres is purely case sensitive. Okay, why it is important to know that Postgres is case sensitive is because if you look at the top example here, you created a table with just two columns and made the first column. If you make the first column as a primary key, then it allows duplicate values, okay, as long as it uses a different case. Okay, but if you are using a primary key, then it shouldn't, right? So knowing these differences is pretty important when migrating to Postgres, knowing that Postgres is a case sensitive. Okay, so here the data is case sensitive in Postgres, but the schema, is case insensitive. That means you can create you can create, if you create a table name in Postgres, it is the name of the table is case insensitive, but the data is case sensitive. Okay. Okay. So how to achieve case insensitivity in Postgres? So there are four methods that are available in Postgres to achieve case insensitivities, but each has its own pros and cons. Okay. So the most common method is using lower or upper functions in the where clause. So if you use lower of a lower function with the column name and pass any key value, then you can achieve the case insensitivity. But make sure that if you use any function in the where clause, then it won't pick the index. It goes for a table scan. In Postgres, we call it as a sequential scan, right? To address that issue, you have to create a functional index which supports in Postgres. In Postgres, you can create an index using functions. So here you can use a function like as in create index customers and lower customer ID, lower or upper, whatever the function that you use, that you pass it on to your select statements. Then it actually uses the index. Okay. Along with this, you can also use I like as an operator, but pay attention to this. I like works only with gin or gist indexes, because I like won't use our regular B tree index. You have to create a gin or gist index. Okay. And the third one is sitetext. Sitetext is also very common method to achieve case insensitivity, because it's a data type and also it's an extension. You have to create an extension to use this sitetext as a data type. Okay. But if you use sitetext with different collations, then your results may vary. So if you're using different collation settings for different languages, then pay attention to how the sitetext behaves when applying a different set of collations. Okay. And the last one is ICU collation. So this I don't recommend, because now you can set the collation at database level. The columns must be explicitly mentioned in the collation. Okay. And another problem is certain pattern matching queries doesn't support, and it might returns error when using the ICU collation. So the most common one are the top three, and using and knowing this pros and cons when using across these three operators, then you can pick and choose the one, no, which fits to your environment or your workloads. So here the case sensitivity about the schema, as I mentioned earlier, the schema is case insensitive. And one more major difference with Postgres is if you create a table with a by using a camel case format, Postgres converts this camel case name to a smaller case table. Okay, so here, though we are using a camel case when creating a table, it converts this into a smaller case. So the problem is, if you migrate your objects from SQL Server to Postgres, which has column casing in object names, but when migrating to Postgres, it converts to smaller case. So it's recommended to use underscore between these using the underscore kind of a naming convention, some naming conventions, to avoid any such confusion. But knowing this difference is pretty important, because in for one of the workload where I was working, the table names and the store procedure names are using camel casing, where after migrating to Postgres, without knowing that it converts to lowercase, it leads to a lot of confusion, because it's from readability standpoint of view, it's so hard to read some of the object names when it converts everything into lowercase. So this is one thing that you need to pay attention to when migrating from SQL to Postgres. Yep. And the next one is data types. So most of the data types are common between SQL Server and Postgres, but here I'm highlighting the data types which you need to pay attention to. Starting with the char data type. The char data type in SQL Server, the max length is 8012 bytes, because that's the total size of the page. But in Postgres, you can create the char data type up to 10 MB. Okay. And the next one is nvarchar. In SQL Server, we use nvarchar to store Unicode values, but in Postgres, you don't need to define nvarchar, because you just have to use the varchar, and since it follows UTF-8 standards, and it automatically allocates the storage based on the character what you feed into that particular column, and you don't need to define it as an nvarchar and pre-allocate doubles the size like as in SQL Server. And the third one is timestamp. This is the big difference because in SQL Server we use timestamp for row versioning, but in Postgres the timestamp data type is actually a date type. Okay, so that's a one difference that you need to pay attention to. But to implement timestamp feature in Postgres, you can define the column as a big integer or integer, and you can define a trigger to keep track of the row versions in Postgres. And the fourth one is a money data type. In SQL Server, the precision and scale is you can get up to 4 digits after the decimal. But if you use the money data type in Postgres, it's only two digits after decimal. Okay? So for most of the use cases, these 2 digits after decimal works. But if your application is an kind of an financial or scientific notation based application where every single digit matters, then you have to use an appropriate data type using numeric, or you can create a custom data type to store your money values, to store your money data. And the fifth one is a hierarchy ID. In Postgres, hierarchy ID doesn't support, there is no built-in data type like as in hierarchy, but there is an extension that supports this hierarchy feature in Postgres. Okay? And the next one, where binary image, for that we have byte, and for date we have date and timestamp, and for bit, decimal, float, for all these numerics we have similar data types in Postgres. And geography, geometry, we have this by default in Postgres as well. But the XML in SQL Server has more features than Postgres because SQL Server has pretty good support on XML. But in Postgres, instead Postgres has better support on JSON than XML. So that is one difference that you need to be aware of, because when planning migrating from SQL Server to Postgres, pay attention to XML, and if you can, then try to convert the source code which is in XML by using JSON to get more and better features. Okay. Yeah. And the next one is identity keys. So both SQL Server and Postgres supports identity or the sequence, and this is the syntax at a very high level that shows that it supports sequencing columns. And concurrency control. So this is a very important thing in Postgres. Concurrency. So let's have a look at this picture. On right hand side you see SQL Server, and on the left hand side you see SQL Server, and on the right hand side you see the Postgres. So in SQL Server, let's assume that it has only 3 records. Okay, and where one user is writing the top record, and at the same time, if another user is trying to read the same record, then SQL Server blocks the other users, because in SQL Server, readers get blocked by writers under default isolation level, right? But there is a way to avoid this by using no lock, or or um, 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 or there's an uncommitted isolation level in SQL Server to avoid this blocking. But if you use no lock or read uncommitted isolation level, then you get dirty data, right? But not to get dirty data, you can use another isolation level in SQL Server that's called a snapshot isolation level. So in SQL Server, if you apply a snapshot isolation level, then what it does is it maintains the row versions in the tempdb database. So the writers will access the actual database to write the data. And at the same time, if any reader is trying to access the data which is currently updating by another writer, then it can read the data from its previous versions, which is stored in the tempdb database. So this is how exactly it works in Postgres. In Postgres, if a user is currently if a writer is currently updating a row, and at the same time another user is trying to read the same row, then this user won't be get blocked, because this user can read the previous version of this record, because Postgres maintains multiple versions to control the concurrent users. So that's the reason it is MVCC, because there's multiple versions MV to control concurrency, which is by default in Postgres. But unlike in SQL Server, where it stores the previous versions in tempdb, Postgres keeps all these versions within the same table. But over a period, you will be accumulated with a lot of row versions, right? But we don't need all these row versions. So there is a process called vacuum, which is a daemon process which runs at the background, which cleans up all these dead rows or the dead tuples at the background. Okay. Yeah. So this is the way how it controls the concurrency. And in Postgres, you don't see any blocking and no dirty rates in Postgres. Okay. So this is what the vacuum that I was talking about. So all these dead tuples will be, it will be removed using a daemon process called the auto vacuum. And you can also run a manual vacuum using a command called vacuum. And this vacuum you can configure at the cluster level or at the table level as well. Okay. Next one. So here, the transaction isolation levels. So, I mean, you don't need to read through the entire thing because there's a lot of data over here, but pay attention to the blocking nature in Postgres when applying a certain isolation level. So here, the first column has all isolation levels that includes read committed, repeatable, write serializable, and read uncommitted. Okay, snapshot and read uncommitted. In Postgres, you can use the read uncommitted, but it behaves like as a read committed because in Postgres, it won't give any dirty data at all. Okay. So though you mentioned, it still behaves like as a read committed. And now in SQL Server, writers blocks the readers when using the default isolation level, right? And this kind of blocking, you will see it in the SQL Server at various degrees when applying certain isolation levels. But in Postgres, there won't be any blocking at all. When applying, irrespective of whatever the isolation level that you use, there won't be any blocking at all. But if you use the serializable isolation level in Postgres, which is at a very high degree of isolation level, then you may see error. Then you may see timeouts. You will be seeing more number of timeouts when applying the serializable isolation level in Postgres. So this is at a very high level. I just want to show you the isolation. The blocking nature between SQL Server and Postgres by default, and when applying certain isolation levels in Postgres. Okay. Now, system databases. Um, in SQL Server, we have master model MSDB and TempDB, but in Postgres, there is a common confusion that Postgres comes with the default databases and Postgres, which is called as a system database, but that's not correct. Okay, that's a default database that comes with Postgres, but it doesn't store any system information. Okay, because Postgres stores all system related metadata and the information at the file level, at internal file level, and it exposes this metadata to all these databases. Okay. And the model database in Postgres is called template, and in Postgres there is no MSDB because there is no SQL Server agent, and the tempdb. In Postgres, temp schema is at the database level, not at the cluster level. So for each database, there is a temp schema in Postgres. Okay. So the hierarchy is same. The object hierarchy is same like as in SQL Server because SQL Server has server, database, schema, tables, views, stored procedures, triggers, and so on and etc. etc. The same thing you will see it in the Postgres as well. Okay. And the second major difference is in SQL Server, each database has its own transaction log. But in Postgres, there'll be only one transaction log for all these databases. Okay. Why it is important to know this difference is because if you want to log ship one database in SQL Server, it is possible to log ship because the transaction log is per database. But in Postgres, you cannot log ship just one database. You have to log ship the entire databases because the transaction log is common for all these databases. And the pros and cons between these two is, let's say if you split the data across different databases, and if you log ship, then you get the consistent data across all these databases in Postgres. So that's an advantage if you look into the other side of it. Okay. And also if you want to sorry and also if you want to log ship only a specific database, then there are ways to log ship a specific database using a replication method called the logical replication as well. And the next one is all tables in SQL Server stored in one or more files, but in Postgres, each table stores in its own physical file. The advantage of having its own file for each table is, let's say if you truncate or drop any table, let's say if it's a staging table, or if you truncate or drop any table, then it immediately releases the space back to the storage. But in SQL Server, you need to truncate or drop, and after that, you have to shrink that file, or else it won't release the space. That's a difference. Okay, and both SQL and Postgres supports file group. And the last one is the cross database queries. So in SQL Server, by default, it supports the cross database queries because you have to use the in three-part naming convention that starts with the scheme, that starts with the database schema and the table name. But in the Postgres, by default, it doesn't support cross database queries. But for that, you have to use an extension called the Postgres FDW. Using this extension, you can achieve cross database queries in Postgres. Okay. And tables. By default, all tables are on same physical file, but in Postgres, each table is in a separate file, as I covered in the previous slide. And this file is 1 GB is in size. Okay. And fill factor. Fill factor is common for both SQL and Postgres. Postgres also supports the fill factor. And the partitioning, SQL Server has list, range, and I think there is one more type of partition that is introduced in 2019 or 2022. That I'm not 100% sure because this is based on SQL Server 2016 that when I made this presentation. But in 2022 or 2019, there might be another type of partition that might be introduced. Okay, that I need to check. Okay. But in Postgres, it has list, range, and has partitions that supports. Okay. And SQL Server doesn't support inheritance because it's an RDBMS, but Postgres, being an ORDBMS, it supports inheritance, which I covered in the first slide in this presentation. Okay. And indexes. So this is very important for SQL Server DBAs. Why? Because in SQL Server, when you define a primary key, by default it creates a clustered index, right? Which sorts the data physically. But in Postgres, assume that in Postgres, by default, all indexes are non-clustered indexes because because Postgres doesn't support clustered index at all. You cannot define a clustered index. But if you have to sort the data physically in your table based on an index, then there is a way to do it. That method is called clustering. Okay, but that's a one-time operation. Okay, so you can sort the data based on an existing index using a command called cluster. So here, this is the command called cluster on a table called employees using employee underscore ind. This is an existing index. So when you apply this command and alter this table and cluster this, then it sorts the data based on an existing index. But this index won't be get updated with ongoing changes. It's in one time. So what's the use case for this? You can the most common use case is if you have a read only table where 99% are reads, then if you see any benefit by sorting this entire data physically or ordering this data by using an existing index, then you can cluster this table. But this is not recommended for OLTP kind of an environment. Okay. And non-clustered index. Non-clustered index in Postgres is what similar to the SQL Server because it's always as a separate structure, which is by default. And Postgres offers more number of indexes that includes a B tree, hash, gist engine, and block range indexes. Yeah. And it also supports filtered and composite, um, filtered, include, and composite indexes like as in SQL Server. And the last thing is index on view. This is very important. Why? Because if you use on SQL Server, we call indexed views because that when you create an index on a view, it contains it refreshes with all the changes that are happening on the table. But on Postgres, there is no indexed view. It's called as a materialized view. That means you still can create an index on a view, but it's a materialized one. That means it's just a snapshot and it won't reflect with ongoing changes on the table. Okay, so the major use case is again if you have a read-only environment or if you want to provide a snapshot of data with some aggregated functions to your end users, then this is one such feature that you can use in Postgres. But this is not as similar like as an indexed view in SQL Server. Okay. So statistics on SQL Server and Postgres. In SQL Server, it's just like as in SQL Server, it automatically updates the statistics as and when it reaches a certain threshold. The threshold you can configure at the table level and at the database level as well. So here you can configure the statistics using auto vacuum analyze scale factor and auto vacuum analyze threshold. Okay. And you can set the statistics, updating the statistics at the table level as well as in Postgres. Okay, because in SQL Server you cannot configure the statistics at the table level, but on the Postgres side you can configure when to collect the statistics at the table as well. at the table level as well. And the command to update the statistics is update statistics in SQL Server. But in Postgres, there is a command called analyze. Analyze following with the table name that collects the statistics. And to monitor in Postgres, it is pg stat user tables, because this is a very handy table. I will explain more about this table in the upcoming slide. But using this table, you can monitor when was the last time that the stats are updated across all your tables in your database. Right. So the other objects like the views, it supports all the objects like as in views, triggers on a views, and DDL, DML, and event-based triggers and functions and procedures. Everything, whatever there in SQL Server, supported by the Postgres as well, with few differences. And these differences I'll cover it in the upcoming slide, because these differences, especially on when to choose functions over procedures, that you need to know. So the next section is development. So when I was learning Postgres with SQL Server background, the first error what I got is this. Because in SQL Server you can print any message by using a print command. But the equivalent to print any message in Postgres is raise notice. So when I apply raise notice, I get this error. Then I was wondering like what is the mistake that I did, and I started searching in Google and spent a lot of time. And from there my journey started. So here the difference is the print command in SQL Server is a transact SQL command. But in Postgres uses PL/PG/SQL, which is a block structured programming language, which I'll cover it in the following slides. But every command, as long as if it is not an ANSI SQL, it has to keep it in a block. Okay. So here, before jumping into PL/PG/SQL, let's look at what is common between SQL and Postgres. In terms of coding, both SQL Server and Postgres, they both supports ANSI SQL. That means all select statement, all create, select, update, insert, all the select statements, as long as it follows the ANSI standards, it supports both in SQL and Postgres. But if you use any proprietary based commands like as in print or create function or create cursors or these kind of things, then this has to be since these are proprietary to that particular database engine, you have to follow certain things. Okay. Because SQL Server Transact SQL is proprietary to SQL Server, but in Postgres it's a PL/PG SQL, which is proprietary to Postgres. And if you're using any command, which is, some of the examples are if you're defining a variable or if then while or a print or procedures or triggers, it has to be in a block, because Postgres is a block structured programming language. Remember the print statement that I mentioned earlier? That print statement has to be keep it within a block, then only it works, because that's a PL/PG SQL statement. It's not an ANSI SQL statement, right? So this is an example. So on SQL Server side, you can mention print following with a statement, following with whatever the line that you want to print. But on Postgres, the same line, okay, this text has to be included within a block, because this is a block structured programming language. The block you can keep it in within single quotes, following with begin and end, and you can execute this block using a command called do. Okay, but here the question is, if you use any single quotes within this line, then you had to replace one single quote with 4 quotes in SQL Server, right? So the same thing in the Postgres as well. So to avoid that confusion, you can replace this single quote with a dollar dollar. Okay, in that way, even if there are any single quotes within this statement, you don't need to replace with 4 quotes. Okay, in that way, your code looks neat and simpler. So this is a complete. Okay, this is an example on how to define a variable and print the value inside a variable. So defining a variable is a PL. It's not an ANSI. It's not an ANSI SQL compliant. It is an PL/PG SQL command, right? So for that, every command, if it belongs to PL/PG SQL type, then it must be included within the block. So here I am declaring a variable, but I am keeping within this block dollar dollar using a dollar dollar, and then I am using a raise info, which is equivalent to print command, and then I am passing the certain statement. I am referring this variable over here. using a percentage symbol. Okay, so this is it's a very important to know this difference and treat this as a block structure programming language. Once you can understand this block structure programming language by keeping certain commands within this block, then most of your programming learning will be unblocked, right? So here I am creating a function, but what I did was the same block what I defined in the previous slide. I just replaced the do function with a create function. That's it. Create function and returns the function return type following with the same block. So this and the previous slide both are same. Only difference is I just replaced the do command with create function over here. That's it. So this is the first step to learn how to create a functions in Postgres, right? Yes. And so in the previous example, this is the function to print a statement. And in this example, this function is for table valued function. In Postgres, you can create a table valued function in n number of ways. Okay, all these ways are even described in our workshop, which I will send it at the end of this presentation. Okay, but this is at a very high level. You can create a function in Postgres using a returns set of customers. Okay, using this command, a return set of customers means, so here we are returning a table. So using set of this customers as in I'm using this customers table like as in type. Okay, set of customers as select star from customers using a language called SQL. Okay, and to create a dynamic function, because in SQL Server we create dynamic functions by passing n number of parameters where the output will change depending on the parameters that you pass, right? In Postgres, you can achieve the same by using this syntax. Okay, you still can return a table. Okay, the table structure is common. Okay, but you can change the value over here by passing the value to that particular column. And there are more ways to create the dynamic functions in Postgres, and all these examples are mentioned in our workshop. Okay, but here in this presentation, since we have only like in 1 hour, I'm covering only these examples at a very high level. All right. So here, functions. SQL Server supports scalar and table valued, but Postgres supports scalar, table valued, and void function. That means you can create a function without returning any value itself. Okay. And both supports explicit. Both doesn't support explicit transactions or explicit handling. Okay. But the function overloading you will see only in Postgres. And in SQL Server, you cannot update or you cannot create any table. You cannot update or create any table using a function. But in Postgres, you can update, delete, insert, select, and even create a table inside a function. If most of the statements will work within a function in Postgres. Okay. And also including creating a temp table and a dynamic SQL that is allowed in Postgres. So most of the things you can achieve by using the functions itself in Postgres, instead procedures. Okay, but when to use procedures? So here, if you look at it, the functions, you can produce result sets to make it. No, you can create a simple function to return a result set and include multi result sets. Okay, but updates with explicit transaction, the transaction control, explicit transactions are not allowed inside a function in Postgres. But if you want to use an explicit transaction, then only use the procedures, or else it's better to use functions. That's a major top one difference. Okay, and exception handling. So here the exception handling, this is the syntax where in SQL Server use begin try and end try, but in Postgres you just have to use the exception following with the exception type. Okay, so for each exception there are several exception types that includes division by zero and a few more others. For each exception type, you can catch it and you can print it, or you can take further action. Okay. But if you want to see all the exception, no matter whatever the exception type it is, if you still want to capture, then you can use exception type as others instead of specific exception type in Postgres. All right. So the security, the most one such common confusion I would like to resolve here is in SQL Server we have logins, roles, and users, but in Postgres logins, user, roles are synonymous, and the only difference is if a role has a grant, if a role has a connect permission, a user with a connect permission act as a role, or else it will be like as in login. And how to distinguish user from the login is if a user has a grant permission in a database, then it becomes a user. That's the only difference. Okay. And like SQL Server has several roles like sysadmin and etc. But on Postgres side, we have roles at the cluster level as well, like super user, create role, and create database roles. And just like as in SQL Server, the privileges are similar to SQL Server, like as in Postgres. And backups. Okay. So backups for logical statement level backup, you can use PG dump in Postgres, which is consistent. That means you can, when you use the PG dump, then it actually soft lock at the beginning of this entire transaction, and then you will get a consistent view of the data at the end of this PG dump. Okay. But in SQL Server, for an logical level, there are n ways to do it in SQL Server using GUI, or you can use the BCP and few more other ways to do it in SQL Server. But for physical backups, you have to do at a file system level backup. If you are using, I mean, if you're hosting Postgres on an EC2 instance or Postgres, any non-cloud Postgres environment, then you have to take the backup at the file level. Okay, but if you are using Amazon ODS or Amazon Aurora, especially with the Amazon Aurora, you don't need to do any backups because it does a continuous backups. That's a major advantage of using managed database engines such as in AWS Aurora. Okay. And replication in SQL Server, you have mirroring, logical replication, merge, and log shipping. But the equivalent in Postgres is streaming and the logical replication. And for merge, we have an extension called PG Active, but of course it brings some conflicts. So you have to be pretty sure about how to handle these conflicts when using any active or the merge replication either in SQL Server or in Postgres. And the log shipping in SQL Server is database level because for every database there is a log file, but on Postgres it's at the cluster level for all the databases. And again, if you are using Amazon Aurora, you don't need to configure any replication at all because Aurora shares the same storage. And you can create up to 15 read replicas where all the writers and the readers shares the same storage, and you don't need to configure any replication at all. Okay, that I will cover it in the following slide about this Amazon Aurora. Okay, but this is at a very high level. Okay, and import export in I think in SQL Server latest version, you still can read the data from a CSV file, but in Postgres you can use an extension to read the data from CSV file. And the equivalent for BCP is copy command in Postgres. And there is another extension that I want to introduce here called the PG loader. Using this PG loader, you can actually load the data and redirect the bad rows. Just like as in SSIS, we define the data flow and redirect the failed rows, right? So to achieve that kind of functionality in Postgres, you can use the PG loader to redirect the bad rows. Okay? Yeah. And if you want to export data directly to an S3 bucket, then especially if you're using AWS Amazon Aurora, then you can use an extension called AWS S3 extension to copy data directly to an S3 bucket. Okay, so that's another extension that comes with Amazon Aurora. Okay, and monitoring, just like as in SQL Server, Postgres also provides several DMVs called PG. Some of the DMVs are the PG stat user tables and the PG stat archiver and a few more. But here I just want to show you the most important table, which is the PG stat user tables. Because using this table, you can see when is the last time that the statistics are updated across all these tables in your database. And when was the last time vacuum ran across all these tables in your database. So this is a pretty handy tool that you must be aware of to see the health state of your tables across all these databases in your cluster. Okay. And also pay attention to monitoring two variables over here. Okay, this is to monitor the transaction ID exhaustion. Okay, and in this session we don't cover the transaction ID exhaustion in Postgres because that takes more time and that's out of scope for this. Okay, but I highly recommend to go through what is a transaction ID exhaustion in Postgres because that is very important. Okay, and backups we use the archive following with the cron tab extension to schedule jobs in Postgres, and to monitor the backups we can use the pgstat archiver, and also several third party tools are available to monitor these backups. But again, if you use cloud native database engine such as an RDS or Postgres, there are other ways to monitor these backups, and you don't, and especially if you're using Amazon Aurora, you don't need to even schedule or take care of these backups even because it does a continuous backup and it does by itself. And there are some other DMVs for monitoring, and there are more, but these are the important DMVs that comes with Postgres, like pgstat statements to look at the top 10 resource intensive queries, and stat activities similar to sysprocess, and stat IO tables and IO indexes to monitor the IO activity at the table level and at the indexes level. And there are some commands to cancel or terminate any transactions compared to the kill command, like what you have in SQL Server in Postgres as well. Okay, and if you're using AWS RDS or Amazon Aurora, we have free tools available for monitoring. That includes, you can use CloudWatch, enhancing metrics, and performance insights, which are come by default. And most of these are free, even up to certain days, to monitor your environment. Okay. And now, so here, Aurora for PostgreSQL. So this is a Postgres on Aurora. So here I'll explain this Aurora at a very high level. Okay. So here, Aurora comes with 99% SLAs and lot of other features that includes, so you can create Aurora, like as in you can use serverless or in standalone Aurora, and a global database and encryption, and a compatible, of course, it's compatible with MySQL and Postgres, and a durable storage, PITR, and a cloning, 15 read replicas, proxies, auto scaling, and integration with all other services like the EKS, Lambda, CloudTrail, KMS, IAM, and there are so many things that comes with the Aurora. Okay, and with pay per use pricing. So in the next slide, so these are all the features at a very high level, but in the next slide, I'll explain like Aurora architecture at a very high level. So here in Aurora, the compute and storage are isolated from each other. And the major advantage of isolating this compute and storage is, just in case if there is any issue that happens at the compute level, then you can easily can replace with another compute instance and attach to the same storage. In that way, you can either upscale or downscale your compute instances, or you can even replace your compute instance during any glitch at the compute or at the network or at any level, right? And the another major advantage, especially with the Aurora, is its storage, because in Aurora every single write, let's say if you are inserting one record, every record, it takes 6 copies of the same record, and it stores that record into 3 availability zones. So each one are 3 availability zones. An availability zone is nothing but it's an geographically distinct, closely geographically distinct, isolated locations within a same region. Okay, so it takes 6 copies with 2 copies on each availability zone. So every record is available in 3 zones with 6 copies, and the quorum for write is 4. That means as and when it writes to 4 nodes, it commits the writes, and quorum for reads is 3. That means as and when at least 3 copies are available across any of these nodes, across any of these availability zones, then it allows reads. Okay, and let's say if there is any issue with any of this storage node, then it automatically fix that node by taking the copy of the data from the another node using a peer-to-peer gossip protocol. Okay, so this makes the Aurora, and also we take the continuous backups directly to S3. You don't need to schedule any backup. Okay, so the storage architecture in Aurora makes that Aurora highly fault tolerant, durable, and resilient. Okay, so that makes the Aurora, this architecture supports all these features what I covered in this previous slide. Okay, the basic, the the underground Aurora architecture. Okay, yeah, and this is at a very high level. This is how the Aurora looks like. So here there is a compute instance, because you connect to this compute instance using a writer endpoint. Okay, so there is an endpoint to connect to this compute instance, and either using your client or in web application, you connect to this endpoint, and this endpoint connects to this writer instance, and this writer instance uses a storage. Okay, so here there are two nodes uh, in each, as it takes two copies in each availability zone. Okay, and with the multiple nodes within each availability zone. Okay, and all the writes will goes to these nodes, right? And it's a shared storage. That means even if you create a reader endpoint, it creates a reader instance, and you can create up to 15 read replicas, and all these 15 read replicas will share the same storage. So there is no replication. There's no, you don't need any replication between writers and readers, since it shares the same storage. And along with this, we have blue green feature, where by pushing a button, it creates a green environment where you can make all the changes to the green, and you can fail out to the green, no, to support the blue green kind of features. And the clones. So just like as in SQL Server snapshot, Aurora Postgres also offers a feature called a clone. So using the clone, even if the database size is in 1 terabyte, let's say not 1 terabyte, let's say 80 terabytes, you can take a copy of this database by creating a clone, and using clone, it creates a copy of the database just in 3 minutes, in few minutes, because the clone uses the virtual storage. Okay, and along with this, we have global database. That means you can create a DR in another region with a one push of a button, where it synchronizes the storage across different regions, and you can have up to 5 regions and have a DR. And you can also bring the data close to the users at their regions by creating a read instances at those regions. Okay, so this is at a very high level on this Aurora architecture. So yeah, with that said, thank you so much for Postgres group for providing this opportunity to us. And if you want to learn more about with an hands-on workshop, then please scan this QR code or click on this link, so that we can schedule a dedicated 6-hour session for your organization, to continue from there. So that's it. Thank you so much, and thanks everyone for attending this session. And let us know if you have any questions.
Thank you, Chandra, for such an insightful presentation. We're opening to Q&A right now, and we already have one question that I think it's related uh, with the last part of the presentation. I think we can answer that. What's the version? What are the Postgres version compatibility with Aurora today?
Okay, so the version compatibility. So we almost close to the community release, and every day we are making changes, and I had to look at what's been changed since past this week. But I think we are supporting up to version 17. Yeah, we just released 17, I believe.
Thank you, Chandra. Thank you, everyone. Hope that you all have a nice day.